Hi, Lena. Hi, Merla. Lee. Nicholas. Julian K. Noah. Sarah. Tadashi. Larissa. Isabella. Vincent. Magdalena. Shilpa. Riley. And Lily. That's a good bunch of you. Okay, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're short a few more. I'm sorry I'm late. I had to change rooms. I was in Mr. Lee's room and the live stream there did not work at all. It was really pixely for my AP Chem class. So I'm in school because I want to do a demo with you, and I will try now and do this here. I hope you can see well enough. I'll try and hold things close to the camera, okay? Because we have to see some stuff about alcohols and other things, and it's time to do this. I can't put it off. There's Natalie and Julian L. Super. So that's now 12, 13, 14, 15, 16, 17. That's pretty good. Well, we'll get probably a few more. I'll add those in. Okay, so I hope it won't be too pixely for you, but just try and write down what I tell you, okay? We're going to do an experiment with alcohol. Ethanol is the one we're going to use. So we're going to add 50.0 liters of ethanol. And some of you know the German word for this. It's Spiritus. Okay. Plus, and there's Dominic. Good. Welcome, Dominic. We're up to 18. That's cool. And we're going to add that to 50 milliliters distilled water. Sounds simple, right? Okay, let's see what happens. Okay, I'm going to throw some goggles on. Here we go. And I've got a couple of graduated cylinders. And I've got to use, first off, this to get my 50 milliliters of water. I'll face it to me. Whoops. Actually, let's turn it down a bit so you can see what I'm doing. Ready? All right. Okay, so here we go. I need exactly 50, so I'm going to be really careful here and slow down when I get close to 50. And I got Ollie there as well. Okay, I'll write you in a second, Ollie. And remember, there's a dip called the meniscus, and we look at the lower part of that, right? You know what I mean? So in a cylinder, when you're measuring, you want to look at this lower part. I'm going to put my eye right here to look at that, okay? All right, I'm getting close. I need a couple more drops to get right on 50. And I am there. Hallelujah. So I got 50 exactly. Let me make sure I've got it right. 10, 20, 30, 40, 50. Yeah, that's the way I want it, okay? So there's exactly 50 of distilled water, okay? You'll see why I'm doing this, okay? Let me write down that I got Ollie here too. And Priya's here. Thank you, Lily. That's okay, Priya. Thanks for telling me. That's good. Oh, Tom is here too. Good, Tom. Okay, so hold that aside. Let's get the spiritus and pour that in. And for this, I may have to use a pipette to adjust it if I can't get it right. Okay, so here we go. Yeah, I'm gonna have to like just pour it a little like this first. Sorry, you can't see that so well. It's not a very nice pouring thing. Tell you what, the hell with it. Let's just fill it up and I'll take some out with a pipette. Good God, it's a big mess. It just sort of sprays all over. What a big mess. Okay, that actually might be 50. Let me wait and see how it looks. It's just a hair too much, dang it. Okay, let's see if I can take some out with a pipette. Now it's too little. And now it's perfect. Okay, so I've got exactly, let me cover up the source here. I've got exactly 50 milliliters of spiritus. I'm trying to hold that up so you can see. And 50 of the water. So it's at 50, and that one's clearly at 50 also. Let's put them together. Okay, here we go. Getting every drop out. Whoops, the bottom is dripping, but that's the alcohol that was on the outside. So I got all 50 with all 50, and I got some on my laptop from the outer stuff, not the inner stuff. All right, okay. Now, I got to tell you, it's warm, and we want to write that down. It's definitely warmer. Whoa. What does that mean? Well, something's happening. Now, we're going to look at the level together. I'll turn it so you can see it. And the volume is not 100. It's like about 98. Let me look and really try and give you an accurate number. It's not even that. It's 91 then. It's 97.7 or 8 maybe. So it is definitely not 100. So it's weird, isn't it? So 50 plus 50 equals 97.8 milliliters with a big weird exclamation point. And of course, the question we're going to answer, and we may not do it all today because I want to do the demos today and maybe the answers another day with you. But the question we want to answer eventually is why? What do you suppose happened? Maybe you can guess a little bit now. What do you suppose happened with the molecules of the water and the spiritus? Ooh, it's definitely still warm. Still warm. And by the way, if I mix it with I think it's already pretty mixed, but I'll mix it just to let you know I'm not doing anything weird. Mix it with a stirring rod. And I'm trying to let it all drain off. So I'm not cheating here. It's not all stuck on the stirring rod. And yep, still the same, like 97 point something. And by the way, some bubbles are coming up, but that's, you know what that is? It's so warm, the dissolved air that's in both solutions is leaving. But that's not what's affecting the volume. Okay, there's something else. Okay, and let's take Shilpa's idea. She says the ethanol falls between the spaces left by the water, causing the size of the ethanol molecules are smaller than the waters. Now, actually, the ethanols are bigger, so it's not going to be a space thing, but you're on the right track, Shilpa, when you say that they're going to get closer together. Turns out there's an attraction between the ethanol molecules and the water molecules, and we're going to find out what that is. Yes, good. It becomes more dense. That's a good way to say it, Larissa. So I think we'd have to say that it's the same amount of mass in a lower volume, so it is denser. That's a good observation. Let me write that. So you can see that. So it's denser. So it's denser. Yeah, that's cool. Okay, I think I'm going to give you the answer now without an explanation. But more or less, Shilpa and Larissa are both on a good track. Maybe some others out there as well. The waters, well, how about water molecules and ethanol molecules come closer together. And if you think about it, that's kind of what has to happen, doesn't it? The water molecules and the ethanol have got to come closer together because it's definitely denser, as Larissa has observed, yeah, from the data here. Closer, so I'll say they came closer due to a new term which we're going to start to study, hydrogen bonding. Hydrogen bonding. And I'm going to give you the name in German as well, because I actually like it better in German. In German, it's, let's see if you can read this, Wasserstoff. Broken. Wasserstoffbrücken. So it's bridges, if you like, connections between hydrogens and other things. Will this happen with every alcohol? The short answer is no. Thank you for asking. Some bigger alcohols have, instead of hydrogen bonding, they have something else going on. And interestingly enough, Noah, we're going to look at a bigger alkanol called octanol. So instead of ethanol, we're going to use octanol as part of our next lab, which is going to be now. Okay, we're going to discuss hydrogen bonding on another day because it will take us a long time. It's interesting, but it's not easy. Underline hydrogen bonding. Whoops, sorry. Everybody underline hydrogen bonding, and then we'll come back to it and we'll talk about it probably when I'm back in my home office, as it were. Okay? All right, let's go to our experiment number 2, unless you got any last observations about experiment 1. All right, so we're going to analyze what brought these molecules together another day. Let's make that experiment 1, shall we? We can add a little 1 on your notes, okay? Experiment 2. Solubility. So what is solubility? Well, it's how well things dissolve in each other. We're going to make a chart and put several things together and see if they're soluble or not, okay? You think about it, we've got data already from our first experiment that we can put in here. Okay, so item 1, item 2, solubility. And by solubility, we're gonna say like high or low. Does it dissolve in each other or not? High or low. Okay, the first 2 items we already did, right? H2O and ethanol. And can you type in, everybody? What was our solubility for those 2? What was our solubility when I added water and ethanol? Just so I know you're following, okay? Thank you, Lily. Good. Let's see some others pump in here with 2 answers as well. Or other answers. Yeah, Tadashi and Magdalene, others. Good. Okay, right. So it's clearly high solubility. Which makes sense, right? If you think about it, isn't this the basis of a lot of alcoholic drinks? Because ethanol is the stuff in beer and wine, but also stuff like vodka and rum and whatever. So you've got a mix in all these things, beer, wine, vodka, rum, whatever, of alcohol and water and then other stuff, right? Okay, I'm going to put that aside now so I don't knock it over. Let's add some other things, okay? Let's do the thing Noah asked about next. This time, to make this a little faster, I'm going to use little cute flask to do this, so I can shake them a little, or I can use a stirring rod if I need to. Okay, I'm going to do some water, H2O, and maybe we should put the formulas. Can we put the formulas too? How about this? Ethanol is C2H5OH. You know what I'm saying? So C2H5OH, that's ethanol. What we're going to use now is octanol. Now, we talked about how we're naming these, and still we've got a main parent chain of 8, right? And then we'll just call this, I think it's 1-octanol. Hello. Yeah, it is. This is one octanol. And so it's C8, H not 18, but 17, and then OH. Okay, that's octanol. Question for you from last time. What does the 1 mean for octanol? Who can answer that? What does the 1 mean for octanol before we pour these two together? The 1 means what for octanol? Super. Thank you, Tom. Thank you, Magdalena, Shilpa. Yeah, it means the OH is on the first carbon. So it's a location of the hydroxyl unit. So it's on carbon number 1. Okay, good. Let's put some together. I'm leaning over too much. Okay, here's my octanol. Now, I don't need to measure it out really because I just want some of both. So I'm going to pour some in my flask. Whoa, is there any in there? Yeah, there is. Not a lot, so maybe I better not use a lot. On the other hand, I need some more. Do I need it for anything else this year? I guess I don't. I'm going to use it up and then tell our lab technician. All right? So that is dead. Ay, caramba. My flask was almost dead. Okay, I'll put that on its side. And here we go. So there it is. So I got that much octanol. Okay, let's put some water in. All right, so I tried to put about the same amount of the still water in there. And I'm going to let them, it's all kind of cloudy. And I'm going to let it clear a bit. And then I'll show you what's going on. Ooh, that's so cool. I hope you can see that. I've got a line. And it's a line right here. I don't know if you can see that or not. And you know what? Other than just, you know how you mix salad dressing and then it kind of goes back to the vinegar and oil if you stop? Yeah, it turns out if I use octanol, exactly right, Shilpa, it's a low solubility. Those, they can see it better on this side. Look at that. See what I'm saying? So those suckers, there's like a clear part on top and there's something on the bottom. I don't know which is which. I'd have to look up the density. I'm guessing the alcohol's less dense. I'm guessing the alcohol's on top, but I don't really remember. So it's a low solubility. Why is that? We're going to find out in class. Okay? We're going to find out in class. But it's good you'll have this chart, and that really came out nice this year. They clearly are not mixing very well. So no, Noah, it looks like all alcohols are not the same. We'll find out when one is soluble in water and when not. Okay, that one's done. We'll put that over here. Here's an old friend from last year. Some of you used this with me. And it's heptane. Heptane, so it's an alkane. Heptane. And hepta, you guys probably remember, is how many C's? Oh, no, I had a question here. Does the solubility directly correspond to its new volume? Yeah, in a way. Um, let's just say the more C's, the less soluble it is, Noah, as we'll find out. Thank you, everybody. So C7, H, double it, add to 16. I'm going to add that to water. Okay. Let me double check the label. Yeah, that's my heptane. Pour some in here. All right. Okay, there's my heptane, just so you know. So that's how much I got so far. Let's add some water. Okay, and I added some water. And similar to when we had the octanol. Check it out. It is definitely dividing into two parts. Let's see if I can get that as close as I can to you so you can see. And I'm seeing the dividing line right here. You see that dividing line there? Kind of cool, huh? You shake it a little bit, you can see the dividing line. And for that one, I do know the heptane is less dense. So the water's down here, the heptane's at the top. Solubility, folks? Heptane in water, solubility? Thank you, Lily, Noah, Sarah, and others. It is also very low. Huge. One more time with water. And this time we're going to add, well, let's just put some water in there. So there's my distilled water. NaCl. So there's my salt. I put it in there, my table salt, my NaCl. I think I can just shake this one. I don't think I need a stirring rod, but let's have a look. I know this one's probably not a surprise to you, okay? Whoa, the salt is gone. Look at that. So not surprisingly, salt and water, table salt, NaCl. The solubility, gang, is high. Thank you. Yeah. One last one. Let's try it in. Ooh, I kind of screwed up. Can I still do that? Well, let's try it in the heptane, okay? Shilpa asked a question that is there a correlation between the number of C's and how soluble it is with water? Yes, there is. And I'm going to give you that data. In fact, I have it. I'm going to scan it and send it to you. Thank you for asking. And you'll have that data, Shilpa and others. Okay, I think it's the last one we'll do. By the way, in this room, am I really pixely or can you see me and the board okay? How is this room? Can you see me and the chalkboard or is it very pixely? Because I did another group and it did not work at all. So I got yes, it's all good. Okay, thank you, Sarah. Thank you, Isabella. Okay, there's my ethanol. No, not ethanol. What did I just put in there? Heptane. Remember, heptane is something that's in gasoline along with octane. I think the most common is octane, but there's some heptane in there too. It's another liquid, so that could run your family car. Let's see if salt dissolves in there. Swirly, 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 swirly. And ew, it is not looking good. I think you don't want to put salt in your gas tank, do you? Solubility is. Thank you, Marilla. Thank you, Natalie. Solubility is definitely low. So we've got a, thanks everybody. Thanks for participating. We've got a real mix of results, don't we? And I'm going to refer back to this starting now and in the other days that we do. We had another question from Magdalena, which was, can I dissolve two alcohols in each other? And the answer is yin. Turns out if they have a similar number of carbons, Magdalena, they will dissolve in each other, like methanol and ethanol will dissolve. Or I could have heptanol and octanol will dissolve in each other. But I can't put the two together. Well, let's try and do that, shall we? Wait a minute, I used up all the octanol, didn't I? Frickin' A. Okay. I used the octanol up. That's not going to work out, is it? Too bad. There it is, but I can't get it out of there. All right. Let's see if I got, let's just see if I got any more octanol, okay? Hold on. Don't go away. I'm back. I got some heptanol, one heptanol. Let's try and mix that with some ethanol, and let's just see how soluble they are, okay? I got one more little flask, so that's perfect. Perfect way to end our day. So I think I'll put in the ethanol first because that's kind of a mess. I'll do it out here away from my laptop. All right, there's my ethanol, just so you know how much I have in there. Okay. All right, here's my heptanol. Ooh, look at it. It looks really cool. It's got like little kind of weird gooey bits in it. unfortunately for solubility, I'm not sure the gooey bits are going to make these dissolve. I'm going to now swirl it a little bit. They're dissolving a bit. Maybe they will. By the way, it's not warm. They did dissolve. Now that one I did not know. Okay, so when I added my two alcohols, ethanol and heptanol, we did get a high solubility. At first I wasn't so sure, but it did dissolve. That kind of surprised me a little bit, but I'll look it up. We'll figure it out. Okay, cool, good. When do I see you again? I don't have my schedule. I think I see you Friday. I think I'm going to do this. You don't know enough. How can I say this nicely? You don't know enough to do an assignment yet on this. So I don't think I can give you much of anything, except I'm going to give you this sheet on alcohols that I talked to Shopa about. So I'm going to send that to you. But other than that, I think that's where we're going to stop for today, because this is not the best spot for me to start explaining things. And I think on Friday, I will meet you and we will talk about our results of the solubility experiment. So experiment 2 today, right? And we'll do experiment 1 and talk about the results there as well. So I think that's it. Questions from you about this, other questions that you have. We put together most of the stuff I could think of. And we had some good observations and guesses from all of you. Any other things you want to ask about today? Okay, so that's it. We're going to end class a little early today. I've got another live stream to do and record for my 9th grade. So I'm going to say farewell, and I'll see you on Friday. And I'll go up and get that paper now and scan it and send it to you with the alcohols. I think that'll be assignment. I'm just going to have you read through that data. Okay? What an alkane do in an alcohol? It won't dissolve. It won't dissolve. It won't be soluble. We'll see why, Magdalena. Okay, I will say bye then. Bye.